Welcome to Border City Data for this month. My name is Doug Sartori. I am the principal consultant at Parallel 42 Systems, and I'm also a panelist on the data podcast, Mean, Median, and Moose. Today, we are going to be exploring the ETL tools that you can use with Microsoft SQL Server, and we're going to use election data to demonstrate it. And without further ado, because we do have an awful lot of stuff to talk about today, this is our agenda. I'm going to describe the problem that we're facing and my proposed solution, share some of the data sources that we will use in this process. Then we'll get into the tools that we're using, a little bit of detail on those tools. I'll share my database design and explain my rationale. We will dig into the guts of the SSIS package, that's SQL Server Integration Services, the SSIS package that actually does the work of transforming our data. As a little bonus, I'll share some stuff that I've been working on around adding geospatial data to this data set. And finally, I'll show off some of the tools, sort of the things that we can do with this data once we've got it all loaded up into the database. So that is our agenda. Okay, so the basic problem that we're trying to solve here is managing to evaluate election data across Canada at the granularity of the poll. Elections Canada produces a wealth of data on election results in this country. Usually about 5 to 6 months after a general election, they will release poll by poll data. And so what that is the election results in every single poll in every single riding in Canada. The format that they use to do that is a single CSV file summarizing the results in that particular riding or electoral district. So you'll get a package of 338 CSV files. It's pretty handy for analyzing the results of a single election in a single riding. But if you want to do anything nationwide, it gets pretty cumbersome and time consuming. So I thought that a relational database storing data at the granularity of the poll for every riding in Canada would allow me to do more complex queries and find out more detailed information about elections in Canada more quickly. And so that was the rationale behind this project, and that is the reason for the solution design. So just a little bit more detail. I'm not sure how politically savvy everyone on this call or watching later on YouTube. I'm not sure how politically savvy you are, or even if you're Canadian. So a poll is an area of a neighborhood in a single riding. Typically, it's 400 or 500 people that all reside in one area. And if you have ever voted in a Canadian general election, you kind of know the process. You go to the polling place. When you get to the polling place, the Elections Canada workers will direct you to a specific desk where they will check your information, give you a ballot, and let you drop it in the box. That box contains all of the votes of your neighbors who reside in the same poll. So that's what we're talking about when we're talking about a poll. And the great thing about poll by poll data, and the reason it's so valuable to get election results at the poll level, is that they're small enough and geographically constrained. So it gives you an opportunity to understand the election results in the riding at a neighborhood by neighborhood level. And that information, combined with things like demographic information or information about incomes, as well as if you were part of a political campaign, as well as the campaign's own information about things like their canvass results, combining all of that allows you to do a very detailed and sophisticated analysis of voting patterns in a specific electoral district. So that's the reason why poll by poll data is so valuable. This is what my data source looks like. Elections Canada publishes poll-by-poll data in two formats. This is actually format 2, and it's really helpful that they do that. They're basically the difference between the two formats. Format 1 is a crosstab that is useful if you're actually working with this stuff in Excel. It lists the candidate names in columns across the top, and polls in rows down the sheet. And that's pretty useful, again, if you want to do some analysis within a tool like Excel. But format 2 gives us one row per candidate. So this is fantastic. Not so easy for working with in Excel, but fantastic for our purposes, which is to get this data out of this format and into a format that we can do fancier things with in terms of composing queries. So there's a URL there, and you can find election results for 2015 and 2019 in these formats. So the work that I've done is to load 2015 and 2019 election results into a database. In a few months, when 2021 data is available, then I'll have the opportunity to load that as well. And then we'll be able to compare 3 elections worth of data all within the same tool. So that's the data source. And as I alluded to, this is a Microsoft-centric solution. We are using Microsoft SQL Server, or SQL Server if you prefer. That's our data store. That's where our data will live. And in order to get that data out of the CSV files where it lives and into the database, we're going to use SQL Server Integration Services, which is Microsoft's tool for ETL, extract, transform, and load operations. This tool is designed so that you can create solutions that are relatively code-free. I did not have to write any code besides a little bit of SQL code for this particular solution. And it's a visual programming language, so you actually get to see the work that you're doing by dragging different elements and transformations and so forth onto a canvas. It's a nice tool to work with, and we'll get a detailed look at it in a few moments. So when I designed this database, I wanted to enable as many different uses of it as would be possible. So what I did is design the database according to traditional relational principles. So this is a database that is almost in the third normal form. The third normal form being a level of relational integrity, first, second, and third. Normally, the third normal form is where you want to land in your design. Typically, when I'm designing a database professionally, I will design it to the third normal form, then selectively denormalize for my application. I didn't do that here. And when we get into the actual queries that we have to write to work with this database, you're going to see some of the trade-offs there. The benefit of a relational design like this is that it gives you strong guarantees of data integrity. It is very unlikely in a properly designed relational database like this that you are going to run into data anomalies. So for instance, in a CSV file that shows poll-by-poll election results, you might have a candidate's name misspelled in one of the rows. That's something that possibly could happen. If that happens, you now have 2 versions of the truth that you have to reconcile and deal with. Those type of problems are eliminated in a relational design. Of course, it comes with its own challenges, but we'll get into that later. So there are a couple things I wanted to mention to you here. Poll boundaries are not necessarily consistent between elections. Actually, electoral districts are not necessarily consistent between elections. The geography of Canadian elections is not fixed. Riding boundaries change, new ridings are created, sometimes ridings are split and so forth. And also, even when riding boundaries are stable, polls can change. The numeration of polls, the actual identifier attached to a poll, is not consistent between elections. This presents a pretty big challenge in analyzing and comparing election results between campaigns. For example, if you wanted to compare election results in 2015 against results in 2019 in the riding that I'm in, Windsor West, you can't simply say poll 100 in 2015 and compare it against poll 100 in 2019. And because poll 100 is a completely different geography in 2015 versus 2019. I'm not really sure why Elections Canada does this. It poses a real challenge for analysis, but we have to recognize that in our database design. And we also recognize that the electoral district can change between elections. So there is an election year column in the ED table, which represents the electoral district. And that column is there to differentiate between a riding in 2015, a riding in 2019, and a riding in the future. They can be different. We also then have a set of polls in the poll table. Each poll is attached to, is connected to through a foreign key relationship, and you see that enumerated in the diagram by the key EDID. It's a foreign key in the poll table. It's a primary key in the ED table. And that means that each and every poll belongs to one and only one electoral district in one and only one election year. We also have the candidate table, and this is also an interesting one because we often see repeat candidates in Canadian elections, but we're not guaranteed that that candidate will be running for the same party or that that candidate will necessarily be running in the same electoral district. So the way that we've modeled this is that the each candidate in an electoral district in a given year has their own record. If that same person runs again, there will be a new record for that person attached to the electoral district for the following year. So modeling it this way, you can probably start to get a sense of what some of the complexities of actually working with this data are, but modeling this way gives us the maximum power available in terms of our ability to analyze this data at a very granular level. So one thing that doesn't change between elections is parties. We have a set of parties in Canada that they sometimes do go away, they sometimes do grow, or they sometimes do emerge, new parties emerge and other parties go away. But generally speaking, especially when you're talking about the 3 or 4 major parties in Canada, they're pretty consistent. So this design recognizes that parties are consistent. We do not have a separate entry for every party in every election year. The party is either represented in an electoral district or they're not, but those parties are consistent. So that's our database design. And it's probably helpful for you to keep this in mind and keep some of those complexities in mind as we go forward. Okay, so with that in mind, let's take a look, and you'll just have to bear with me a moment as I swap out the screen that I'm sharing. This is not a seamless process. Here we go. All right, so what we're looking at now is the SSIS package that actually takes those election results, comma separated value files, and turns them into data in the database. As I mentioned, SSIS is a tool that is visual in nature. You do not have to write a ton of code. Generally speaking, with SSIS, you compose your solution with building blocks that you can visualize on screen. What we're looking at right now is the control flow. So a few things that I want to orient for you in this package and on this screen. On the left-hand side, we have a toolbox which contains, this is context sensitive and it will change as we move to different pieces of the application. But what it contains is the tasks that we can execute on the canvas, the tasks that can make up a part of our solution. So you can see that there are a number of different tasks, mostly for dealing with IO in some way, either getting data from an FTP site or getting data from some other data source. Sometimes we need to actually do transformations and whatnot on the data, but that doesn't live on the control flow tab. That lives in the data flow. Over here on the right, we have our Solution Explorer and our Properties pane. The Properties pane allows us to get into some of the detailed properties of the different elements of the solution. And down here at the bottom, you see our connection managers. In this case, I have two connections. I have a connection to the election results database that we are feeding. And I have a connection to the CSV file that we're drawing from. But if you remember, when I described the data sources, we're not dealing with one CSV file. We're dealing with 338 CSV files that we need to individually process. So the first thing that we have to do is figure out how we're going to deal with those 338 files, because we wouldn't want to have to enumerate them all in our solution. So when I open up the connection manager, and I'm not sure if you folks can see this screen actually, now that I think about it. So I am just going to change my share so that I'm sharing the entire screen here. I see a question from Lee about links to the data sources. Yes, absolutely. I'll in fact go one better than that as we go through this process. So anyway, when I double click on my data source here, now hopefully everyone can see it. What you may notice here in this connection manager is that the file name is blank. The actual file name of the CSV file to process is blank. And the reason for that is that we are using some other tools in SSIS to fill in that blank and fill in the specific file we're working on, each in turn as we work on it. So we're using a for loop construct here. Okay, you can see that it's called loop elections Canada files. And when I double click on that so that I can bring up the details, so the for each loop container allows us to iterate over items in an enumeration. In this case, we are iterating over the items in this specific folder. So there is my downloads folder. There is the location of the poll by poll folder that contains all of those CSV files. And we are going to use a wildcard to process every single file. Okay. And then we actually take that value, we take the value of the file name, and we populate it into a variable. So that variable is called user file name. Okay. We can take a peek at the variables in our SSIS package. We have two. One is for the election year. The other is for the file name. The election year variable will come into play at the end, and the file name variable comes into play in our for each loop. So how this works is, I'm going to pop over to my connection manager again and look into the properties panel. And there's a little plus sign beside this, this row called expressions. I expand expressions, and you can see now there is a the value connection string. Okay, so that's the property connection string. The property connection string is actually using an expression. In this case, it's a real simple expression. It is simply the name of the variable file name. So you can see now how that flows, I hope. We have a blank in our connection manager for the flat file. We have a variable that stores the file name of the current iteration of the loop, okay? That variable is then used in the connection string property through an expression of the connection manager to identify which specific file we're working on. I hope that was clear. And through that technique, we're able to operate on every single file in that folder. Okay, so what are we doing with those files in that folder? Well, at a high level, you can see each of these tasks. And I want you to recall that database diagram. The reason that we are executing each of these tasks in this particular order is because of the dependency structure of the tables in our database. We, in order to populate a party with a value, we need to be able to associate it with an electoral district. In order to populate a candidate with a value, we need to be able to associate it with a party and an electoral district. And a poll needs to have a electoral district as well. We also need to know all of that other information. And finally, poll result is our table that stores the actual votes accrued by each candidate in a given poll. So we populate these in sequence according to their dependencies. And to do that, each of these boxes that you see is actually a data flow task to itself. So when I double click on a single data flow task, we'll start with the electoral district. Now we're on the data flow canvas. And you can see that our SSIS toolbox has now changed. Rather than dealing with control flow tools, now we're dealing specifically with data flow tools. And this canvas is all about moving data through the transformation process. So we start here with a source, a data source. Pretty much every data flow needs to have, at minimum, a data source and a destination. In this case, our source is the CSV in our flat file connection manager. So if you remember, we are populating that flat file connection manager with the file that we're operating on in this iteration of the loop. So then we have an opportunity to identify the columns in our input and which columns we are actually going to output. In this case, we're going to output all of them. Okay. Then we have a connector that is connecting the data source to a transformation. In the case of our first data flow, the data flow for the electoral district, it's pretty simple because all we need to do is populate the database with this data. We don't need to worry about any existing keys or any existing data. For simplicity's sake, we are assuming that this tool is always going to be used on an empty database. That's pretty important. If you were going to use this tool on a database that may or may not already contain data for that particular election year, we would have to do some other things. But for the sake of simplicity, we're assuming we're always operating on an empty database. Okay, we are looking right now at the sort transformation. So we are using the sort transformation in this case to output a limited subset of columns. And the most important thing that we're doing here is removing duplicates, okay? That is actually the reason we're using the sort transform, and we're using it throughout the solution, not because we care about the order of our data, but because we want to deduplicate our data. So this little checkbox down here deduplicates our data and guarantees us that we are only going to get one output value in our data flow for every electoral district number, which is perfect. If our data source had more than one ED in one file, this would work. But in this case, it's great. We actually only need to get this information once because the electoral district number is going to be the same for every row in this file. And all we want is the first one. So the transform, the sort transformation gives us that single row, that single value that we care about. And then we are able to populate it. So basically, we have a destination, and in our destination editor, we identify by mapping through this visual tool how the input columns map to the destination columns. So in this case, you can see that every single column in the ED table is represented here, but we are actually not populating the election year, okay? And we are not populating the ED ID. Two different reasons. The reason that we're not populating the ED ID is that it's a primary key that is automatically generated by the database. So we don't want to supply a value for that. In fact, the database wouldn't let us. The election year, we're going to populate way at the end of this process. And that is, the reason for that is that we do not have a column in our data source that identifies the election year. Okay, that's not information that is embedded in that CSV file. So there is no way for us to populate it. Fortunately, it's only one value that we have to populate across the entire set of data that we're importing. So it's not a big problem. And I'll show you how we handle that a little bit later. So essentially, this is the process of moving data from a source to a destination. We identify which data we're interested in. We do whatever transformation operations that we need to do in order to change that data to accommodate what we need in our destination. Then we use mappings on the destination editor to identify exactly which columns map to which. And then you're off to the races. Okay, so that's the simple one. That is the electoral district data flow. And we're not going to go through every one of these in that level of detail because they're mostly the same. What I want to do is walk you through this and show you the differences. Once we have electoral districts loaded, then we're able to load parties. And if you remember in our data design, we actually identify in each electoral district the parties, okay? So once again, we have our data source, the CSV file that was identified through our loop, variable, and expression combination. And once again, the data source looks exactly the same. One thing I want you to note, we are reprocessing the same file at every iteration of this, every single iteration of this entire process. Every data flow is reprocessing that same file over and over again. Okay, so in this case, we once again use a sort transform, and once again, for the same reason, we are removing all duplicates and we are finding the unique political parties that are standing for election, have a candidate standing for election in this electoral district. Okay, so again, even though these party names will be repeated hundreds of times in our CSV, we are removing duplicates and we're using the sort transform to remove those duplicates. So we only get the data that we actually care about adding to our database. Okay, but we've got a problem now. Unlike the electoral districts, we know that there is, per CSV file, there is only one electoral district, and we're only going to process every file once in terms of how many times it's running through the loop. So we don't have to look anything up when we are populating EDs, because also remember that every electoral district is unique to its year. So assuming that there's no data, which we are operating under the assumption that there is no data already in the database for this election year, we can just go ahead and insert every single electoral district into the database. We can't do that with parties, because as soon as you start processing the second electoral district, you're going to be dealing with parties that already exist. We want to make sure we process each file because we want to make sure that every party that runs even one candidate in Canada is represented in our database, but we don't want to repeat them. So this transformation, the lookup transformation, what this transformation does for us is it is looking up the party by name and checking if it exists in the database. If we have a match, then we actually throw that data away in this case. And you can see that we have a trailing arrow on the data flow that has no destination. The reason that we do that is that we actually don't care about those rows. If there is already a conservative party of Canada in the database, we do not need to add it again. Okay, we connect to our election results database. We are looking specifically in the party table. And what we're doing is we are looking, you can see what we're doing here. We are looking for the using the political affiliation in our data source and looking to see if it matches in English the name of a party that's already there. And if it does, then we are going to output the party ID. Okay, so this is a lookup transformation. It's often used in a different way. In this case, we're using it essentially to identify any parties that are in the CSV we're processing who have not been added to the database yet and add them. So with that in mind, we only use the no match output, not the match output. So the no match output from our lookup, meaning here is data that has no match in our database. And that means we know that there's no party there, we need to insert it. And then just as we've done with the electoral district data, we take the information that we care about, which is the political affiliation name, that's the party name in English and French, and we use it to add a new record to our database. Once again, we are not interested in populating the party ID column because that's a primary key in the database. Okay. So now what we've got, we've worked through those first two data flows. We have a database that is populated with an electoral district. Now remember, this is all iterative. So this process is repeated 338 times, once for every CSV file. We've populated our electoral district. We've populated any party names that don't exist in our electoral district or in our database so far. We populate those. Then we are populating the candidates. Okay, so a lot of this is going to start to look familiar because we're using the same data source and a very similar destination every single time. But this time we have to do an extra step. So we've got our Elections Canada CSV file. Then we use the sort tool to only get unique candidate names, just like every other element that we've looked at so far. These candidate names are repeated hundreds of times in this CSV. We only need one. So that's what we use that transform for. Then we look up, and now we're using the lookup transform not to identify things that don't exist in the database, but to find data that already does exist in the database. So in this case, we are not concerned that our candidate already exists. And we've talked about that when we went over the database design. We do not want to use one record for a candidate because too many things about that candidate could change between elections. So we insert a new candidate. Now, you can only run in one electoral district in Canada. You can't run in two, you can't run in five. So we can be confident that we don't need to look in the database to see if that candidate exists. We know that it doesn't. But what we do have to do is we have to get the IDs that we need to populate that, that table correctly. So we need, when we populate a candidate in our candidate table, we need to identify their party and we need to identify what electoral district they are part of. So in order to do that, we use a lookup transform. In this case, what we are doing is we are looking up based on the political affiliation name that is listed in the CSV for that particular candidate. We are matching that up against the party name in our database. Remember, in the previous step, we populated these. We are matching that up against the party name, and then we are passing through that party ID column. That is going to be the data that we add through this step. So we're now, once this is finished, this lookup transform, we have looked up the party ID and we've added that to our output. Okay, so now our output is going to contain that extra piece of information, the party ID. Then in the next step, we do the same process, but instead, we are now looking at the electoral districts, and we are looking for the matching electoral district number. Now that's the Elections Canada identifier that matches the data from the CSV file so that we can get the ID for this particular electoral district. And so with that data, now when we look at our destination and we look at the mappings, what you can see is we are able to populate the party ID because our data flow has added that column to our data. We're able to populate the electoral district ID because the data flow has added that column to our data. And then we can add in our candidate's first, middle, and last name, as well as a little piece of bonus data, which is whether or not that candidate is an incumbent. That's a piece of information that comes to us in the CSV, and we might as well use it because it could come in handy. Okay, so once we've done all that, and we're going to move a little bit more quickly now, we do the same thing to populate each poll. So in this case, we are using our same CSV file, and now we're looking for all of the unique polling station numbers, removing duplicates. We are looking up the electoral district ID, just like we did before, by the Elections Canada number that's in the CSV to get that EDID, and then we're populating our destination. Okay, and in this case, there's the electoral district ID, and we're populating the polling station information, okay, including some interesting stuff that we're going to be able to use later. So here's another instance where we're taking data from the CSV file. In this case, it is the number of electors. Okay, so now we know how many people actually are eligible to vote in that polling station, as well as the number of rejected ballots. Rejected ballots are not associated with any specific candidate, so they are properly associated with the poll as a whole. One thing I want to mention is that there are a couple of ways that I could have done this. I wanted to do this in a way that would allow me to show off the capabilities of SSIS, and that's why you're seeing it done with transformations like this. Those of you who've got some experience with SQL Server might be, or another relational database tool, might be thinking about ways that you could have done it with pure queries and a little bit less processing time or processing work being done by SSIS. And that's true. You could have looked up those IDs that are relevant by using subqueries in an insert statement into the database. I think that's an equally valid approach. There is no wrong answer here. It just depends on what you're trying to accomplish. And I think also who is going to be working with or maintaining this in the future. Again, I really wanted to identify a solution that used as much of SSIS's capabilities to solve the problems as I could. Okay, and finally, once we've populated all of the other information, we jump in and we populate the poll result, the actual results in terms of the votes that were accrued. So we do all the same stuff that we did before. We use our Elections Canada CSV. We look up the electoral district. We pass the matching output down, and add that to our output or our set of columns in our data flow. We look up the poll ID, we add that to our columns in our data flow. We look up the candidate, okay? So now we've got all of this information, and what we are going to do in the poll result table, basically we're passing to that the poll ID, okay? What is the internal identifier of the poll in our database? The candidate ID, who is the person who got these votes, and the actual tally of votes for that candidate, okay? That is the general process. And then when that's all done, we have this one extra little task that we do here. And this is the piece that I mentioned at the start. We run a little SQL query to populate the electoral district table, all those rows that we just inserted, all 338 rows we just inserted, with the election year from our election year variable. That was the easiest way to do it. And it's just one little query at the end. And that is essentially our SSIS solution. Okay. I know that was a lot of information. Hopefully it made sense. What we're going to do now is I'm going to stop my share and switch back to my slides very briefly. Okay, so the next thing that I want to talk to you about is something that I added to this database just this week, and that is spatial data. So one of the challenges that I mentioned in working with elections data in Canada is that poll numbers change from election to election. But poll boundaries don't tend to change. Poll boundaries are pretty static. They can change, but they're generally more static than the poll numbers. So it's useful to be able to compare performance in a poll in one election against performance in the same poll in another election, but it's pretty hard to actually do it unless you examine it visually, unless you have a spreadsheet with the information that you're looking for and a map. And you kind of cross-reference between the map for the last election and the map for the next election. It's not a whole lot of fun. So being able to do something to automate that was a goal that I had in mind. So very quickly, and this is just the kind of the 5-minute tour of what I did. Elections Canada produces something that's called a shapefile. Okay. A shapefile that you can download that gives you the geographic information. Okay, and now we're looking at it. The geographic information for all of the polls in Canada. Okay, this should look pretty familiar. This is Canada. I'm going to zoom in on our neck of the woods. Okay, I'm looking at this using a tool called QGIS. QGIS is a open source and free tool for working with map data. It's very, very handy. In this case, there we go, here's Windsor. And now you can get a sense, if you kind of know where Windsor is or know the city of Windsor, you can start to get a sense of how big a poll is and how those polls might help you tell a story about an election. You know, if you're familiar with the city, there's a few things that should jump right out at you. Think that this little oval here is the golf course in South Windsor. We've got Southwood Lakes down here. These would be the railroad tracks, et cetera, et cetera, et cetera. So this is really handy, but how do we use shapefile data in SQL Server? Okay, what we can do is we can take this layer, okay, and we can export it. And the format that we want to use is comma separated values. I learned this the hard way in terms of how I worked with this data. Initially, I was trying to use the the commonly used format for mapping on the web, which is GeoJSON. But GeoJSON is not something that SQL Server natively can work with. You have to do a little bit of hacking to get it to work. So there is a format called WKT, which stands for well-known text. Okay, the WKT format for geography is something that SQL Server natively understands. So I can save this data as a CSV file with WKT geometry for every pole. Okay, and once I've done that, I can hop over to my SQL Server, and now we're looking at my, I hope we're looking at my SQL Server screen. Let me just make sure. Yeah, we are. And now what we're looking at is a subset of that data in my SQL database. So I used the import wizard to import those CSV files into tables. Here they are, polling divisions 2015 and polling divisions 2019. Okay. These are the columns. They should look familiar because these are the columns in the CSV file. There's that WKT, that's our geography. There is the polling division number, that is the poll number, and that federal number, that is the number of the electoral district. So we've got geography, we've got a polling division number, and we have an electoral district number. That is all the information that we need to insert that geography into our database. If you want to take a peek, oh, it's a little too much data. Okay, well, let's take a peek at just a small subset. So what I've done here is I've written a query that joins that geometry data in our PD table to the elections database, the elections results database that I built. And this query joins the geography data to the election results data. And then you can take a look, and that should look familiar if you reside in Windsor West. That is the riding of Windsor West, and you can see every poll is there in a different color. Pretty cool stuff. So the next step, of course, is to actually add that. So I added a column to the poll table, a column that you may have noticed wasn't populated in our SSIS package, the geo column. Okay, and I just ran a couple of update queries. These are the queries right here. To update the geometry column with the specific coordinates for that poll. So now we have geographic data at the poll level. Really exciting stuff, and I'm going to show you in a few minutes. So with all of that done, I have a few minutes left, and I want to show you some of the things that we can do with this database now that we have it. So I've got a few queries saved here that I want to show you. I'm going to talk to you about the queries a little bit beforehand. So what you may notice first and foremost from these queries is that they're not simple. Relational databases tend to lend themselves to complex queries, and the more strict you are in defining the relationships in your database and in atomizing your data into the different entities, the more complex your queries are going to be. The other thing that is important is that when we are creating an output, we have a specific format of data in mind. There is very likely a perfect format for that data analysis, but it's not always the format that you get from your relational database. So a technique that I'm using here that you'll see over and over again in these queries is I'm populating a temporary table so that I can get a table shape that is more easy to work with in the analytical queries. So that's what we're doing here. So the first thing we're doing is dropping the temporary table if it's already there. so that we don't end up with weird data duplicated or whatever. Then I am populating. In one step, I am creating and inserting into the table using select into this temporary table called votes cast. And what we're doing is we're taking the electoral district, okay, and we are grouping our data by electoral district. And then we are getting the number of votes cast, okay, in each poll result, in each specific poll, okay, grouped by riding. So let's take a look at what that looks like. And populate that table. Okay, 338 rows, that's a good number. We were expecting that. And here we go. Here's the total number of votes cast in each riding in 2015 versus 2019, okay? So we're already getting some really cool information. So now we have a table for analysis that is showing us the writing and the number of votes in 2015 and 2019. And now what we can do is write a query, and this query is a little bit complicated, but what it does is it shows us the vote share for every party for every riding in the province, or in the country rather. So you know, we can take the Bloc Québécois. Well, they got 21% in this riding. So we have a query that gives us a result showing us the percentage of the vote that every party got. Well, every major party, I stuck to the big five here. Every major party got in 2015 and 2019, and the change between those 2 years. Okay, pretty cool stuff in my opinion. We can also, by setting up our source table a different way, we can actually, we get this, this one is showing us who won each riding, okay? So first we create a temporary table of candidates, and then we populate it and we query that table to identify who was the winner in each specific riding. And there you go. There are all the ridings in the country. And now we can just quickly query our database and find out who won. I do want to say that generally speaking, these are all queries that are running individually, populating a temporary table and then outputting the information. If we were building an application that was relying on this database, we would probably create stored procedures and views that are elements, you know, that are database objects, so that we can surface this data in an application like a web application or a report. But for demonstration purposes, this is quick, clean, and easy. Another thing that you can do with this data is identify who, okay, so we've got our list of candidates, okay. We can find out who won each riding. Then we can find out who won each specific poll, and then we can count how many polls they won. So rather than counting votes in a riding, we're now counting polls, okay? So let's take a look at what that looks like. How many polls did each candidate win in every riding? And here we go, okay? So the Liberal, in whatever riding this is, 24017, Liberal's name was Mendez, and they won 222 polls. And you can see the other candidates in that same riding didn't do so well. The NDP candidate won 3 polls, the BQ candidate won 1. Okay, pretty cool. But all of that is in the service of this query here. Who won the most polls in each riding? Oh, I see. Okay, let's run the whole thing. Who won the most polls in each riding? And here is that query. Okay, and this is a pretty neat report because it's showing us, here's the riding. Okay, here's the name of the candidate. who won the most polls. Okay, how many polls did they win? And they won 10 more polls than their opponent, but guess what? They didn't win the riding. So some really interesting stuff to be gleaned there. Just another neat way of looking at this data. That's a specific, looking at a specific riding to break down who in this specific riding won the most polls. So anyway, that's another way that you can look at it. And then I thought this one was pretty fun. This query calculates the value, okay, of a specific poll to each party. So what you're looking at here in order by the value of the poll, what you are looking at is, where's that formula? Okay. You're looking at the number of voters for that particular candidate or that particular party over the total number of electors, not the people who cast votes, but the total number of electors. So the most valuable poll in Canada in this particular election was Pinsent Arm in Labrador, and 87% of the electorate in that poll voted Liberal. So that's pretty interesting. I thought that was pretty interesting, so I grabbed some details about that specific poll. There are 39 electors in Pinsent Arm, so an awful lot of them made their way to the polls and voted for one particular candidate. Okay, all of that is pretty cool. I hope you found that interesting. We have about 3 minutes left in our hour, so I want to show you now what the results of that geography import that I did, what the value of that is. As I said at the top, one of the real challenges in evaluating elections in Canada is that we're not able to translate polls from one election to the next because there are so many variables. So what I did is I wrote a query and I chose a specific riding, the riding that I happen to be in, okay, to compare the results from 2015 to 2019. And what I did is used a couple of tricks here. We're using the spatial tools in SQL Server. In this case, the intersection function, which is going to tell us we have a set of polls from 2015 and a set of polls from 2019. Okay, the tables are aliased F and N for 15 and 19. Okay, and so what we're doing is we are looking at what percentage of the poll from 2019 is inside the poll from 2015. Okay, how much of N is inside of F, and then express that as a percentage of the overall area of the poll from 2015. And in our where clause down here, we are only doing that. Here, let me do that, make the syntax a little easier to see. In our where clause down here, we are only including rows where the intersection is greater than 90%. So what that means is that if there is a poll that overlaps because of a data anomaly or a slight change in boundary, we're not going to include that. We're only going to include those polls where we have a strong overlap between the two. And I was curious how useful this would be. It does take a little bit of time because this is a pretty hefty process. I was curious about how useful this would be, about how much actual overlap there is between polls from one election to another. And I was astounded that for the most part, the polls are one-to-one. The geography is more than 99% accurate between the two. I'm talking out this query because it is taking a little bit of time to process. I'm not exactly sure how well this is going to translate at a national level. I haven't done that level of detailed analysis yet, riding by riding by riding. And I'm not sure, even in Windsor West, I'm not sure that we're getting 100% coverage. But even 80 or 90% coverage of the polls is valuable, because that's going to allow us to evaluate the changes between elections in a way that we were really not able to before. Okay, I'm going to go ahead and stop my share while that executes, and we'll get back to that a little bit later. This might be a great time to ask if anybody has any questions. Okay, can you please share your code and design for this project? I absolutely can. If you take a look on my GitHub, github.com/dsartori, DSARTORI, you are going to be looking for the repository called Canadian Election Results. I'm pasting that URL into the chat now. That is the complete solution that we went through today as well. If all you're interested in is a database of election results for Canada, you can take a look in that repository, look in the database files folder, and you're going to find a zip file called election results with data. That's actually an SQL script you can execute. You don't have to run the SSIS package, and you can have all of this data. You can have all of this data in a local database for free. However, if you want to execute the SSIS, you're also going to need those. Elections Canada files, and that information is available to you in the README file for that repository. The README contains links to the Elections Canada files, so you can grab everything you need. Okay, my query has finished. It took a minute and a half, which isn't so long, except when you're waiting for it, and it feels like forever, especially when you're waiting in a demo situation. But here we go. Here is the result. So what we're looking at here is the poll number in 2015, the poll number in 2019, the percentage of correlation. So a 1 here would represent 100%, the candidate's name in 2015, the candidate from that same party in 2019, not necessarily the same person, although in the case of Mr. Massett, he is, and the change in votes from 15 to 19. Okay, so you can see how valuable this can be. And you can see now how maddening it is that Elections Canada changes those poll numbers. So in 2015, it was poll 102. In 2019, it's poll 106. Why? I don't know. One other thing that I can call out while we are looking at this and we're scrolling through this data, I should be able to find one. There we go. One of the other things that happens in practice on the ground is sometimes Elections Canada will split a poll. Maybe they're seeing more people come in the door than the individual election worker can handle. So they'll split a poll into 2 ballot boxes. So you'll see that here, 192A and 192B. That is something that you will see in the data. And in this case, poll 199 in 2019 did not need to be split. So that is a potential source of inaccuracy. That's something that would have to be worked out. But if you download the repository, all of these queries are here. There's lots of stuff for you to play with. And hopefully this has been an interesting and informative session. All right, thanks everybody for joining me today. This was a lot of fun and I hope you enjoyed it as well.